What if a black hole wasn't the end, but a beginning? As matter falls beyond the point of no return, something extraordinary happens. A cosmic rebirth, a hidden universe, governed by laws unknown. Could every black hole be a gateway to a new reality?
When I was young, my grandmother gave me a set of Russian nesting dolls, matryoshkas she called them. I was fascinated by how each doll contained another smaller version of itself. Open one and there's another inside. Open that one and yet another appears. This childhood memory returned to me years later during a late-night conversation with colleagues at a cosmology conference. We were discussing one of the most provocative theories in modern physics, that our entire universe might exist inside a black hole. It sounds like science fiction, doesn't it? But the mathematics suggesting this possibility is surprisingly compelling. What if our universe, all the galaxies, stars, planets, and life forms, is just one of countless universes nested within black holes like cosmic matryoshkas? Tonight, I want to take you on a journey through this theory. We'll explore its mathematical foundations, examine the potential evidence, and consider what it would mean for our understanding of reality if we truly are living inside a black hole. Before we dive into the hypothesis, let's establish what we know about black holes themselves. Black holes form when massive stars collapse under their own gravity, creating regions where space-time is so severely curved that nothing, not even light, can escape once it passes the event horizon. For decades, physicists viewed black holes as cosmic dead ends, places where matter is crushed to infinite density at a singularity, and the laws of physics break down completely. But our understanding has evolved dramatically. We now recognize that black holes aren't completely black. They emit Hawking radiation, a subtle quantum effect predicted by Stephen Hawking in the 1970s. They have temperature, which means they have entropy, and enormous amounts of it. In fact, a single black hole can contain more entropy than all the rest of the universe combined. This suggests they are not simple objects, but perhaps the most complex structures in existence. What happens inside a black hole remains one of physics' greatest mysteries. Our current mathematics can't handle the extreme conditions at the singularity. General relativity, which describes gravity, and quantum mechanics, which governs subatomic particles, give conflicting predictions. This conflict, this mathematical breakdown, is actually the first clue supporting our universe in a black hole hypothesis. In the standard model of cosmology, we believe our universe began as an infinitely dense, infinitely hot singularity that suddenly expanded, aka the Big Bang. But this description is strikingly similar to what some theories suggest might happen inside a black hole if viewed from a different reference frame. Physicist Lee Smolin took this idea further in the 1990s with his theory of cosmological natural selection. He proposed that every black hole in our universe might give birth to a new universe inside it, with slightly modified physical laws. This creates a kind of cosmic evolution, where universes that produce many black holes have more offspring. One of the most puzzling aspects of our universe is the horizon problem. Regions of space on opposite sides of our observable universe couldn't have communicated with each other since the Big Bang, yet they have nearly identical temperatures. It's like finding two people on opposite sides of Earth who've never communicated but somehow wear identical custom-made outfits. The standard explanation is cosmic inflation, a period of exponential expansion in the earliest moments after the Big Bang. But the black hole universe theory offers an alternative explanation. These regions shared information before our universe formed, in the parent universe where our black hole exists. Now let's consider a truly mind-bending aspect of this theory. Inside a black hole, the roles of space and time undergo a radical transformation. What we experience as time moving forward might be perceived as a spatial dimension from outside the black hole. Mathematician Peter Linz described it this way. As an outside observer sees matter falling into a black hole, time appears to slow down until it freezes at the event horizon. But from the perspective of the falling matter, it crosses the event horizon in finite time and experiences what might be a new expansion into a separate space-time, potentially a new universe. The mathematics of general relativity allows for this possibility through what's called white hole solutions. A white hole is the theoretical time reverse of a black hole. Nothing can enter it, but matter and energy can exit. Some physicists have proposed that the Big Bang was essentially a white hole, the other side of a black hole in another universe.